Okay, we are on 12B, so we're continuing on from the previous video. We are asked to find the Taylor series about 0 of this function x over 1 plus x squared. So I solved this in two different ways. There's probably a reason why this professor put this as part B of the question, because he probably wanted or was intending maybe for you to use the answer in part A to answer this question, but you actually don't have to. Okay, so let me show you the faster way to do this, and then the way the professor probably wanted, but probably didn't realize that you can do it a little simpler way. Okay, so we're gonna start with the known Taylor series, 1 over 1 minus x. Hopefully you have this memorized as well. Okay, this is just the geometric, it looks like a geometric series, right? So summation as n goes from 0 to infinity, x to the n. You should memorize this. This is when you first learn power series, you learn something like this, right? This is also the Taylor series of 1 over 1 minus x, centered at 0. Okay, so you should memorize this. This comes up a lot, actually. So we want to get this 1 over 1 minus x to match x over 1 plus x squared. So let's go step by step. Well, I can replace this x with a minus x squared, so it becomes 1 plus x squared on the bottom. Okay, so replace x with minus x squared. That's what I did here. Okay, and then just simplifying. So I wrote it as minus 1 to the n, x to 2n, properties of exponents. So then I just multiply x on both sides, and then I get it matching, right? So x over 1 plus x squared is, well, I multiply x on the right-hand side, I just increment this power of x by 1, 2n plus 1, and you're done. That's why this is the faster method, in my opinion. This is probably not what the professor intended, because you can differentiate and integrate power series. So you can solve it like this. So in the previous problem, or part A, previous parts, we were finding the Taylor series about 0 of ln of 1 plus x, which was right here. Okay, what happens if we differentiate ln of 1 plus x squared? That's just 1 over 1 plus x squared times 2x. Okay, isn't this super close to this, the function that we want? It's just a factor of 2 different, right? Okay, so what did I do in the next line? So I replaced ln of 1 plus x with the power series representation that we found in part A. And then I wrote this 2 out in front to show that this is matching our original guy. Okay, so what happens if we differentiate this power series? You use the power, right? So minus 1 to n plus 1 over n, that's just a constant, leave that alone. X to 2n, we use the power rule. So it's 2n, x to 2n minus 1. Okay, we can simplify the 2's, sorry, the n's, they cancel, right? And the 2 I pulled out in front. Okay, and then this 2 on the left and this 2 on the right would cancel, right? So we can say x over 1 plus x squared is summation as n goes from 1 to infinity of minus 1 to the n plus 1 times x to 2n minus 1. This is an acceptable answer as well. Now notice, it looks kind of different than up here, right? So did I do it wrong in one of the two methods? No. If you re-index this series, it'll match up here. Or the best way to check, just expand it term by term and you'll see it matches. So I'll leave that up to you, or you can just trust me that it's the same answer. Unless I didn't make an error, then please let me know. But otherwise, I believe I checked on Wolfram Alpha that it's expanded out term by term and it matched. So if that's not the case, please let me know and I'll fix it in a comment or something like that. Okay. So this is just two ways, once again, to answer this question. There's the easier way, and it wasn't that bad, but it's technically took more thought and effort than this method one up here. But again, method 2 is probably what the professor intended, even though he probably did not realize, or maybe he did, I don't know, that you can do it this easier way as well. Okay, anyway, hopefully this is helpful, just showing the two different ways that you can arrive at the same answer. As usual, please like and subscribe if you found this helpful, and hopefully see you in another video as well.